Okay, pre-calc, this is where we left off in 8.7. So if the video cut out on you, you can see some of the things. And there's a moral to this. And what you should notice is that when I ask you to graph a log function, you can use some of those clues that we've discussed to be able to come up with the graph without having to use a graphing calculator. Now, if you're allowed to use a graphing calculator, I would encourage you to do so. So again, this is where we left off. So what are the rules? Let me rotate this back. So here is the next part of your notes, where we should establish how to find the equation of the vertical asymptote, as well as the domain of a logarithmic function. And I'll tell you straight up, I usually just do this to figure out what the domain is, because this part, what I just highlighted, will tell me if we're to the right of the vertical asymptote or to the left. And it also tells us the equation of the vertical asymptote, because instead of saying greater than or less than 0, we can just write the vertical asymptote is at x equals whatever that number is. And because the domain of an exponential function is all reals, it's always from negative infinity to infinity, then the range of a logarithmic function should always be negative infinity to infinity. So hit pause before I jump back to the notes, because I will work through the rest of these. And by the way, if you have questions, still write them down and just bring them to class. So for instance, this is what I was talking about. If I was given a log function, I would do the domain first, because we can only log positive numbers, so the argument must be a positive number. Just remind yourself that as you subtract 2 to the right side, 0 minus 2 is negative 2, and you divide each piece by negative 1, just remind yourself that when you divide by a negative, you have to flip that inequality, and negative 2 divided by negative 1 is positive 2. Now, if you want to write it like this, but remember on a multiple choice, you'll probably see my answer written like this. Answers to the left of 2 mean that we go from negative infinity to positive 2. Maybe I'll circle with a different color. So without doing the equation of the vertical asymptote, I already know that the vertical asymptote will be x equals 2. Now, if you don't believe me, do what the note said, which was set the argument equal to 0, and you would have the same work. The only thing is you don't have to consider dividing by a negative does not flip anything for the equation of the vertical asymptote. Now, the range should be very easy for you. It's always all reals. We can get positives and negative answers. And then, the domain actually answers this question if we're to the right or to the left. Well, since we are to less than, it almost looks like an L. I've actually had students that make the less than symbol with their hand, and then they tilt their hand to make it look like an L. Anyway, we are to the left of the vertical asymptote. Now, if it asks for an explanation, I would really appreciate if you looked at the original problem and saw that there was a y-axis reflection. So if there's a justification somewhere in here, you might mention that there's a y-axis reflection. That would be a perfect answer. Okay. You may come up with some other answers, but not as nice as stating that. And just a reminder, this has been a while since I've said it, is if x is negative, then we reflect over the y-axis. So I'm going to do the next one really the same way. And by the way, this negative in front would reflect over the x-axis. But if we were to look at the graph of this log function, I don't know how much time I really want to spend on what the graph of a log function looks like. Typically, it goes up and to the right like this, and at this ordered pair 1, 0. So if we had a x-axis reflection, it goes like this. And the 2 would stretch it out. I don't want to spend too much time talking about this. This is showing us that we would have been to the left of the vertical asymptote and shifted right too. So the vertical asymptote would not have been the y-axis. It would have been shifted to the right too. So play around with a graphing calculator with that and see if that answer makes sense. But again, this is sort of bonus understanding. So let me move on to h of x. So all you really need to do is take the argument and say it needs to be positive. So as you add 3 to the right side and divide by 2, it makes sense that we're looking at 3 halves. Again, right now I'm fine if you just leave it like that, or if you write it in interval notation. And that also tells us the equation of the vertical asymptote. It's x equals 3 halves. And it's fine if you want to work it out the same way that the notes tell you to, but it's really the same work there. The range, as I mentioned, is always all reals. And then because we're going from 3 halves to infinity or to the right of 3 halves, we are to the right of the vertical asymptote. I guess I didn't write of over here. And there's no y-axis reflection. If we go back to our transformations, there's not a negative in front of x, so there's none of that. So if you were to examine what this graph would look like, we are shifted to the right 1.5. So if you were graphing this with a graphing calculator, it would be shifted down 3. So instead of the y-intercept typically being at 1, 0, it's shifted to the right 1.5. So it's like 2.5, and also down 3. So this function looks more like this. But again, we're getting to more of a bonus standard, and you can use a graphing calculator to examine that. So we also need to think about a table. Okay, so we give you f of x and we give you the function, and then it's just reminding you from the previous unit with exponentials, what's the equation of the horizontal asymptote? Well, as I look at all these values, this is getting large. I know it's not like a ridiculously large number, but over here we're getting closer and closer to -3. So that's your equation of the horizontal asymptote, y equals -3, and the explanation I want to see is just that end behavior. As x goes to -infinity, it's labeled f of x is going to -3. Now I'm also a realist that maybe you look at this piece right here and say, oh, well, the equation told me up here that the c value, if you remember from the previous unit, we called that the c value pretty often. Or if you just said it looks like the exponential function is shifted down 3. And I might be getting ahead of myself as well, because I haven't talked much about e being the base. Just a reminder that e is about 2.718. It's greater than 1, so this should be an exponential growth function, shifted to right 2, down 3, which I might actually answer this question next. So I guess I did kind of answer it. Because there's no negative in front, then we are above the horizontal asymptote. So let's write that out. I'll switch back to that color. Above the horizontal asymptote. If we looked at the equation, our reason would be that there's no x-axis reflection. But if we looked at this table only, I'll switch back to that pink color. We have that. And we had the graph kind of look like this. Looks like, I think I drew that pretty well. So we're definitely above, and I'll give you a couple reasons. You can either point to the graph with the table of values or use the no x-axis reflection. So think of it this way. If we are switching the x and y values around, and we have positive values for y, then the inverse function, so if we're above the horizontal asymptote, first of all, that will have a vertical asymptote for the inverse. And being above the horizontal means that will be to the right. To the right of the vertical asymptote. Yeah, that's why I'm confusing myself. But anyway, And I'm just thinking about, well, if we're above for y values, then we need to be to the right for x values, because we'll have positive y values, means we need to have positive x values. You know, I might even show you the answer key on that one, just to, because he uses a lot of words to explain it. But basically the same thing. Above the horizontal asymptote, all the values are bigger than -3. So we need to be to the right of the vertical asymptote because all the values need to be bigger than -3. X needs to be bigger than -3. And you can actually see a few of the next answers. There's really nothing to hide. But it's the same thing. Well, if the horizontal asymptote was y equals -3, and the inverse just means to switch, y's become x's, x equals -3. And your reason could just be simply that you switch x and y. So if we talked about the domain of the original function, well, the domain in an exponential function is all real, so we can plug in anything for x. But if you notice on that range, we could only go from -3 to infinity. And for the inverse, I should label this. This is for f. So for the inverse, we need to switch x and y around. So the domain needs to become the range, and the range needs to become the domain. So the domain goes from -3 to infinity, and then the range is from -infinity to infinity. So before giving you the graph, they want you to practice finding the inverse. Well, we did that in the earlier video, where we took the function they give you, e to the x minus 2 minus 3, and switch x and y around. So x equals e to the y minus 2 minus 3. Minus 2 minus 3. Okay, so the first thing to do is get the exponential form by itself. That would be adding 3 to the left side. I like to give myself some space, so then I can natural log both sides. And then your last step would just be to add 2 over. And I like to write it as f inverse of x instead of y equals natural log of x plus 3. And I have to add 2 to the left side. So if we break it down and sketch the graph of that, then we have a vertical asymptote at x equals -3. And the parent function for log normally goes through the ordered pair 1, 0. So I'm doing this in a different color because I want you to think that this is the parent function. Log base b, any base of 1 is always equal to 0. So if you look at this, you can say, okay, well, let's take that point and shift it left 3 and up 2. And what you should notice is that the x and y value that we had earlier, 2, -2, switched to -2, 2. And you could do that for more values as well, like -2.865, 0. You know, and I could do that for more values, but I think you can also kind of look at that and say, okay, I can tell that it's getting closer and closer to the vertical asymptote this way, and that's going pretty large off to the side. So like 4.3896 would switch around. So 4.3896, 4 would hit somewhere right there. And that's what your graph of the log function would look like. This log function matches that. So I feel pretty good about how I've explained all of this, but feel free to write anything down. You can see some of the work here if you want to hit pause in the video. But with this last page, just go work through it. And as I typically do, I'm going to just share the answer key. But just because you have the answers doesn't mean you necessarily understand. You know, bring questions to class. I guess you've hit pause already or not. If not, you can go back and rewatch it. And you hit pause one more time for that graph, and you should be ready for the homework.